In this video, I'm going to solve two different problems related to the erratic motion. Let's look at one example. A race car starts from rest is mean the initial velocity of the car is 0 and acceleration is given as a function of the time, and from time 0 to time 10 seconds the acceleration is found by this equation. The brakes are then applied and the car has a constant acceleration as a minus 30 feet per second square until it comes to rest. It means the velocity of the car reaches to the 0. Determine the maximum velocity, the total distance traveled, and the total time of interval. Okay, as you can see, for describe the behavior and the motion of this race car, we have two different equations for the accelerations. Okay. For the first time, for the first interval, the velocity is, we can find the velocity by taking derivative from the, by taking integral from the acceleration, because the acceleration has this equation from time 0 to time 10 seconds. For finding the velocity, we can say acceleration is a derivative of the velocity respect to the time. If I take an integral from the acceleration, we can find the velocity. dv. The equation of the function of the acceleration is a 5 plus 2 times t dt. At time 0, the velocity or the initial velocity of the race car is 0, because the problem mentioned the race car is start from rest. We have to find the velocity of the race car at time 10 seconds. When we solve this integral, the velocity equals 5 times t plus 2 times t squared over 2. As you can see, the lower limit of the integral is 0. For this reason, we have v minus 0. Okay, for this one I didn't write. Okay, we have v equal 5 times t plus t cubed. For the part A, we have to find the maximum of the velocity. But as you can see, the velocity is an increasing monotone function. So the maximum of the velocity occurs at the end of the interval, is meaning the maximum of the velocity is happen at time 10 seconds, because the end of this interval is a 10 second. At time 10 seconds, the velocity is 5 times 10 plus 10 to the power 2 is become 150 feet per second square. Again, because the velocity has a monotone function. Okay, this is the answer of the part A, the maximum of the velocity. The next step, we have to find the displacement or the distance traveled. Okay, if I wanted to find the displacement or the position of the car for the first time interval, okay, we know that the velocity is a derivative of the position respect to the time. So we can write ds equal v dt. ds, what is the equation of the velocity? Is 5 times t plus t squared dt. We know that at time 0, the initial position of the race car is 0. We have to find the position of the race car at time 10 seconds. Okay, when we solve this integral, we get s minus, the lower limit of the integral is 0. We plug here, we get 0. 5 times t squared over 2 plus t cubed over 3. So now we have to find the position at time 10 seconds. At time 10 seconds, we can say we have 5 times 10 to the square over 2 plus 10 cubed over 3. So the answer of this part is 583.33 feet. Is meaning at time 10 seconds, the velocity of the race car is 150 feet per second, and the position of the race car is 583.33 feet. We are using these information for the second interval. Okay, for the second interval, we know that we have a constant deceleration is minus 30 feet per second square, and also from the previous slide we know that at time 10 seconds the velocity is 150 feet per second, the position is 583.33 feet. Okay, and we have to find the position and the total time when the velocity of the race car reaches to the 0. What is the time and displacement? Okay. As you can see, we have a constant acceleration. Okay. We can write acceleration is a derivative of the velocity respect to the time. We can write a dt equal dv minus 30 feet per second squared dt dv. When the time is 10 seconds, because this is related about the time bigger than the 10 seconds. Okay, when the time is 10 seconds, the velocity of the race car is 150. We have to find the time when the velocity of the car reaches to the 0. We have minus 30 times t minus the lower limit of the integral, minus 30 times 10 equal v minus 150. We can write log as minus 30 times t plus 300 equal v minus 150. We have to find the time when the velocity of the race car reached to the 0. So we have minus 30 times t plus 300 equal 0 minus 150. When we solve this one, the time is defined as a 15 second. It means at time 15 seconds, the velocity of the race car is 0. Okay. For the second part, we have to find the total displacement of the race car. From this part, we find the equation of the velocity. Okay, maybe I can write the equation of the velocity like as this one. Minus 30 times t plus, if I bring 150 to the left side, we get plus 450 equal v. For finding the position, we have v equal ds over dt. We can write v dt equal ds. What is the velocity? Minus 30 times t plus 450 dt ds. This information is related to the second time interval. Okay, for this reason, the lower limit of the integral is 10 seconds, and from the first interval, we know that at time 10 seconds, the position of the particle is 583.33 feet. We have to find the position when at time 50 seconds that we found in this step. Okay, so when we solve this integral, we get minus 30 times t squared over 2 plus 450 t minus the lower limit of the integral is meaning minus 30 times 10 plus 450 equal s minus 583.33. Okay. If we simplify this equation, we have minus 15 t squared plus 450 t minus this one is around, and this one as a 3000. If we add it here, we get minus 2416.67 equal s. This is the equation of the position for the second interval. So at time 15 seconds, the position of the particle is is 958.33 feet. This is the answer of the part C. If I wanted to summarize all the answer of these problems, okay, I can write here the maximum of the velocity is 150 feet per second. The total time that the velocity of the race car reached to the zero is 15 seconds, and the total displacement of the race car when the velocity of the race car reached to the zero is 958.33 feet. This is the answer of this question. Let's look at the